Hey everyone, Dr. Walker here. This is video 207. It is called Electric versus Gravitational Force. In this video, we are going to compare the electric force and the gravitational force. So just a quick review first. What is the gravitational force? This is the force that we learned about in Physics 1, where we had any two objects that had mass, and there was always a force between them. The objects were always attracted to each other. So this was the expression that we saw for the gravitational force. The force was equal to the gravitational constant times the product of the two masses divided by r squared, where r was the distance between the two masses. So by just seeing this equation, you should be telling yourself, this does look like the electric force that we just learned about. So in the gravitational force, this constant here, g, the gravitational constant, or constant of universal gravitation, was 6.674 times 10 to negative 11. So that was a very small number. And so the masses had to be pretty big in order for this force to be significant. So let's look at comparing and contrasting the two forces. So first of all, the electric force is between charges, while the gravitational force is between masses. Secondly, the electric force can be attractive or repulsive, right? If you have a positive and a negative charge, they're going to attract. If you have a positive and a positive, both positives, they're going to repel. But with the gravitational force, we learned that it was always attractive. Masses are always attracted to each other. The electric force is going to be the stronger force, and the gravitational force is going to be the weaker force. So we saw in Coulomb's law that constant K that came in that equation, F equals KQQ over R squared. Coulomb's law here, Coulomb's constant was 8.99 times 10 to the 9, while the gravitational force, F, is gmm over R squared. The G here is 6.674 times 10 to negative 11. So you can, just by looking at this constant, this shows you how much stronger the electric force is. How are these forces the same? Well, they're both the inverse square laws, and this means that both of them have the r squared in the denominator. So they both depend on the distance between the charges or masses, but they depend on the inverse, right? It's in the bottom and it's squared. So for both of them, when the distance gets bigger, it doesn't matter if it's gmm or kqq, when the distance gets bigger, then the force gets weaker, and vice versa. If the distance gets smaller, then the force gets bigger. A couple more things. Both of these forces act at a distance, so your charges or masses do not have to be touching to experience this force between them. And finally, they're both field forces. In Physics 1, I didn't really talk about fields. It wasn't really needed, but basically, we're going to learn about electric field in the next video. But as far as gravitational field, the way that you can think about it, and it does help to go back to gravity every time we talk about electric force, think about the Earth. And we talked about in Physics 1 that if there's a mass, then it's going to be attracted to the Earth. There's this gravitational force between the two. And we call that the weight of the object was due to this gravitational force between the Earth and this object here. So another way that you can think about it is that the Earth produces this invisible force field, this gravitational field, that it just produces it by virtue of having mass. And whenever an object is placed within this field, then this object is going to experience a force. So you can think of it that it's because this mass is placed within this gravitational field produced by the Earth, that's why this mass is attracted to the Earth. So this is a really good introduction to fields, and that will be the topic of the next video. But first, there will be an example associated with comparing electric forces and gravitational forces. So take a look at that video, and I will see you there.